So hello everyone, my name is Muhammad Faridanoli from Mechanical Engineering 2018. So here is I will present my result about the heat transfer experiment on senior mechanical laboratory subject. So this is the experiment description, and the topic itself is the fan cooler effect on phone CPU temperature. And the purpose or the objective is to determine whether the fan cooler has effect or not to the cooling time of the phone while it heated up. And the scenario is divided by two. So the first is the phone that heated up is not attached without the fan cooler. And then the second is the attached one. And the variable, the first is the cooling time of the phone and also the loaded temperature. So this is the chapter for the experiment settings for each scenario, and let's begin with the pre-experiment. So basically the pre-experiment is the same for both scenario. So we need a phone with Instagram application to load and heat up the phone, and also the CPU's temperature measurement application to record the temperature of the CPU's phone. And the second, we need the stopwatch to measure the cooling time. And also, this is the fan cooler itself for the fan cooler attachment experiment. And we need also the paper and also pen to record every data. And the first that we can do is measure the phone dimension and specification. And also we can measure the dimension and specification of the fan cooler itself. And then this is the with the fan cooler experiment or the scenario one. The first thing to do is we record the initial temperature of the phone, and then we can directly open the Instagram and give the load to the phone for about 5 minutes. And then after that, after the load is given for 5 minutes, we can close the Instagram application and open the measurement temperature application and record every changes during the cooling time. And then the cooling time is when the phone is heated up and then going back to the initial temperature. And for the fan cooler experiment, the procedure is the same. We first record the initial temperature, and after that we open the Instagram and give some load to the phone for about 5 minutes. And the procedure is the same with the first scenario, but the difference is after the phone is given the load, we attach the fan cooler itself to the back of the phone during the measurement on the CPU's temperature during the cooling time. And for the experiment for each scenario, we will do 10 repetition for each scenario. And so this is the result for the first scenario of the experiment, which is the phone that without fan cooler attachment. And then we set the initial temperature for 28 degrees C, and we can see the loaded temperature is vary, and also the cooling time in the average is 2.71 seconds. And then this is the data for the first to fifth repetition on the first scenario, and we can see here uh, it goes back to the initial temperature, but I record the data after it reached the temperature below the initial temperature. And then this is the same. This is the 6 to 10 repetition of the first scenario. And then this is the results for the second scenario of the experiment. And this is the fan cooler setting. And the initial temperature is also the same. The loaded material is also the same. And the loaded temperature here is also vary like the first scenario. And the cooling time here in the average we got 1.29 seconds. And this is the results for the first to fifth repetition of the scenario. And as we can see here, all the data is stopped at 27 degrees C, which is below the initial temperature. And this thing to make sure that the temperature is already going back to the initial temperature and steady. And this is the 6 to 10 repetition of the second scenario. Next part is the analysis. And the first question is there any difference in cooling time between the setting and why? And as we can see on the result chapter, we see that the average of the fan cooler setting, the cooling time is shown 1.29 seconds, and without the fan cooler, the cooling time is 2.71 seconds. So the difference is seen, and we can see that the fan cooler works well in the cooling time of the phone. And why? This is because there is heat transfer process there, and then it elaborate with the second question, how does the fan cooler affect the cooling time? So basically for the fan cooler specification itself, so it works by the cooling system, which is a fan, and it goes through the hot end and also the cooling module, and then it conducts to the cold plate, and then the cold end plate here doing the conduction to the phone. So basically the heat transfer will process from the higher temperature to the lower temperature. So when the phone is heated up, the heat is transferred to the cold end of the plate, and then that is the cooling happen. So this is the last chapter of the presentation, which is the conclusion and expected error. So the first conclusion is that the fan cooler, it does have effect in the cooling CPU's phone temperature, as we can see on the analysis and result chapter, that the second scenario, which is the fan cooler setting, in average have the faster cooling time than the first scenario, which is the phone without the fan cooler attachment. Then the second is that the cooling may work better on phone made from glass or metal. So this is related to the heat transfer factor, which is the on conduction factor, which is there is thermal conductivity of the material. And as we can see that the phone that I used in this experiment is made from plastic. So the back part of the phone that attached to the fan cooler. So it may have the faster time in cooling if we done it using the phone that made from the glass or metal due to its thermal conductivity. And then the possible error that happen on the experiment is the firstly the transition from phone loading to the temperature measurement. So this is caused by the human error on its repetition of the experiment. So the transition time from the loaded phone to the process of recording the temperature changing on the application. And then the second is the measurement error or the bugs on the application. So this is happen on the experiment. So I have to redo some repetition on the first scenario due to the measurement error or bugs that I found in the CPU temperature measurement application. So the bug is that the application need to be restarted before it used, and the temperature itself it doesn't change or it doesn't work when it crashed. So I have to refresh it and then redone the repetition. And then the last possible error is the room temperature itself. So as we know that the cooling time is also can be affected by the surrounding temperature. So the room temperature itself may different if we done the experiment on day and night. And that's all from my presentation. Thank you very much for your attention.